So I appreciate everyone tuning in for the second session here in the Cyber Tech and Risk event today. My presentation, I'm going to throw Brian a curveball and change my title here at the last minute. This is actually a truncated version of that longer presentation that he alluded to. So the talk that I've got for you today, I call Packets a New Hope, Defending the AWS Cloud Using Network Detection and Response. And I'll just call out at the outset that even though my examples in the presentation are all related to AWS, the ideas and the concepts are directly transferable to other clouds, including Azure and GCP. So I've been able to distill the entire presentation into a single slide, which I'll start with to just summarize my thesis for this presentation. And that is this: use packets to find evil in the cloud. It's more fun, or I'll say way more fun, than treading water in the data lake. So with that, let's dive in. And I want to start with the phenomenon of attacker dwell time, because for information security professionals, this is really the elephant in the room for our profession. It's shocking, for instance, that in the year 2020, dwell time is still measured in months, that the average data breach lifecycle from identification of compromise to containment of that compromise is 279 days. So this is really an indictment of all of us in a lot of ways. And it's equally shocking that when these breaches occur, 53% of the time, it's we're not figuring this out ourselves, but someone else is telling us. So some law enforcement agency or other outside entity is coming to us to let us know that we've been breached. Now, what I think this points to the notion that the playing field between defenders and attackers is not level, that attackers actually have a structural advantage over defenders. And I call this dynamic attacker-defender asymmetry. And what I mean by asymmetry is, if you think about it, if you're an attacker, as we saw in the last presentation, the cost to launch attacks is very low. So attackers can launch millions of arrows with little to no effort, and only one of those actually has to land in order for the attacker to get a foothold from which they can build on. Now, the consequences of failure for the attacker are extremely low, and certainly, most of the attacks that are launched against you will in fact fail. But that doesn't dissuade the attackers, because of course the effort to launch them is also very low. Now, on the defender side, it's the reverse. The consequences of failure are very high. So if an attacker gets in, what we know from these dwell time statistics is that the attacker likely will be able to move about, do network reconnaissance, move laterally within your environment for weeks and months without you having any idea. And so really defenders are asked to block all of the arrows, and the consequences for missing one are extremely high. But defenders are having to do this while also managing what is an irreducible attack surface. We all in the profession are experiencing this on a daily basis, that our attack surface is not just complex, but it's dynamic, it's constantly changing, and it's constantly growing. And so, between the nature of the attack surface that we are managing and the assets and information that we are tasked with defending, and the fact that the playing field isn't level, we have to assume breach. So this new paradigm that breaches are inevitable, that we also heard mentioned in the last presentation, is really the prevailing paradigm now. And I'll assume that for the attendees who are here at an event whose theme is cloud detection and response, this is not a new idea for you. So for those that are familiar with the NIST cybersecurity framework, you'll recognize the detection and response pillars, and we are seeing increased investment in these areas as organizations try to supplement their identification and protection measures, which are the first two pillars of the cybersecurity framework. Now, a couple of quick callouts here. You still have to get the basics right. So you still have to have governance practices, risk management practices, asset management practices in place, and have a solid foundation. But the reality is that no matter how well you run your estate, it's unfortunately not enough to prevent breaches from happening. So you have to have this mindset of fast recovery, which requires some kind of early warning capability. Now, one bit of good news for defenders about this new paradigm is that the consequences for failure on the defender side have now become much lower. So if you're able to detect an adversary compromising a workload, but then contain that compromise before it expands to become a full breach, now it doesn't matter if a single arrow lands nearly as much as it used to. That doesn't mean game over. So I want to shift gears and talk about how to detect evil in AWS and respond to it. Now, and again, these ideas are transferable to other cloud providers as well. So broadly speaking, defenders have at their disposal some AWS native tools, which are all log-based, as well as some AWS marketplace tools. Because this talk is on network detection and response, I'm going to focus on packet analyzers in AWS marketplace as part of this talk. Now, for those that are already AWS users, you may be familiar with the well-architected framework and its 5 pillars. For the security pillar, the security pillar answers the question directly: how do you detect and investigate security events? And similar to the on-prem based detection and response workflows, similar to D&R workflows in other cloud providers, the workflows and data sources Amazon recommends are logs and event data. And this really shouldn't come as a surprise to us, because all AWS telemetry is inherently log-based. And taking action on the content of those log messages requires distilling bits of the log messages to events. So if you think about CloudTrail, this is simply a log of all interactions with the AWS management plane. CloudWatch is, of course, Amazon's solution for log analytics. And VPC flow logs you can think of as really cloud NetFlow, and a combination of NetFlow records with cloud firewall logs. EventBridge, formerly known as CloudWatch Events, is what does pattern matching on contents of the logs in order to drive automation and remediation through sources like Lambda or through Security Hub, things like that. So this brings me to what I call the defender's dilemma, which is, stated simply, logs were not made for the business problem space of detection and response, but they're all we've ever had to work with on the blue team. So every SOC workflow is based around the SIM, which is the data lake, if you will, or this central repository for various log sources from across our environment. And this is no different in the cloud. But the fact is that using logs for detection and response has a number of friction areas and a number of pieces of baggage that come along with that. So for instance, logs are inherently post hoc. They're telling us what has already happened. I would submit that behavior detection requires real-time data. Now, 30 seconds may not sound like a long time, but when modern attacks are fast and destructive, the real need is to be able to respond in milliseconds. And when you consider that you can wait for seconds or minutes even from when a compromise occurs to when the log of that compromise is available and actionable in CloudWatch logs or in Guard Duty or in AWS Security Hub. This is really unacceptable, but it represents the present state of the art, before network detection and response comes on the scene. Next, log, and your mileage may vary on this one, but log data is shallow, right? There's a variability in the degree to which systems can self-report their activity and generate logs. And the need here for doing quality behavior detection that doesn't result in a lot of false positives is to have transaction level detail. As we also got a bit of reference to in the last section, presentation, logs are difficult to wrangle. So if you think about what goes into setting up and maintaining a log collection regime, you first have to enable logs everywhere. You then have to centralize and store them. You have to normalize them. You have to parse them and analyze them, figure out how to seamlessly retrieve logs and query them by writing custom queries. Visualize logs, right? Convert them into say time series metrics or charts on dashboards in order to understand which information you want to be notified about. And of course, notifications have their own set of challenges, right? You get into the threshold tuning game to make sure that your notifications are not too noisy. Next, logs are easily disabled. I think everyone understands that, that item number 1 in the attack playbook is to clear out the Windows event logs, right? This is a single command in a interpreter session for someone that gets access to your system. The need to do behavior detection is really to have some set of data that's tamper-proof. And then lastly, this isn't a critique about log suitability for detection and response, but I'll just call out that logs are insanely expensive. So whether I'm working with Azure customers or AWS customers or GCP customers, or even customers protecting data center-based workloads, the amount of storage to back a SIM needs to be ever expanding. And beyond the storage capacity, the cloud providers charge you for the ingest ability for logs. So it turns out that Azure and AWS customers commonly report that log-based monitoring is actually the largest line item on their bill. So, which is a pretty arresting concept if you think about it, that it costs less to run a VM in the cloud than it does to collect and store the information about what that VM is doing from a log perspective. So the question that I would pose is, can we do better? And I would argue that yes, defenders deserve better than these log-based workflows. So let's talk about network detection and response. So Gartner calls NDR the biggest one-step jump to situational awareness from near total unawareness. And there are a number of reasons for why that is. But they all sort of boil down to packet-based analysis is able to completely obviate or mitigate a lot of those friction points that are inherent to dealing with logs. So let me first define my terms. Network detection and response is an early warning system that identifying malicious behavior and containing threat actors by applying machine learning to packet analysis. And when I say packet analysis, I'll further define that as full payload, fully decrypted. So not just talking about looking at packet headers or sliced packets, and I'm not talking about looking at flow records or summarizations of network conversations. Again, that's a form of log data, but I'm talking about the full packet payload and being able to extract various attributes from packet payload. And then, of course, in order to get at the payload of packets for encrypted traffic, which is to say basically all traffic in modern environments, an NDR solution must have the ability to decrypt those, decrypt the TLS, including sessions that are forward secure. So It turns out that packets have a couple of properties, and network data has a couple of properties that makes it uniquely suited to the problem space of detection and response, as opposed to, say, a post-mortem investigation doing root cause analysis, which logs are fantastic for. And those properties, I'll cite three. First is that packets don't lie. Network data is as close to ground truth as you get. It's not self-reported. It can't be disabled. And for instance, the NSA, a guy named Rob Joyce, who runs the National Security Agency here in the United States, their Tailored Access Operations Group, says that the NSA's biggest nightmare is an out-of-band network traffic analyzer, right? That passive network tap that some defender team is paying attention to, because you can't avoid being observed via the network for your attack activity. And then lastly, network data represents the richest data source available to defenders. So I have a couple of examples to make that point, but the main takeaway here is that packet data enables defenders to see the unloggable, both in terms of what information, what behaviors are not able to be self-reported, either because the system, the OS, the application doesn't have the ability to log what is relevant for defenders, or because it would be impractical to log, say, every interaction with every table of every database in your environment. So two examples I want to highlight. First, the Amazon Relational Database Service, what a failed login looks like to a database instance. And then second, using and abusing a bastion host over SSH. So let's take the RDS failed login case. Now, what you're looking at on the screen is an example of what I see in VPC flow logs when I connect to a MySQL database. And you should notice right away that this data set in its raw form is inherently difficult to work with. The fields aren't labeled. You have to have special protocol knowledge about registered ports to know that 3306 represents MySQL. And here the flow log is telling us that the connection attempt was accepted by the database. And if we were to respond to an alert based on this information, we might think that we need to go issue a press release to notify our customers that their sensitive data has been exposed to an attacker. But we really don't know what actually happened. We don't have that transaction level detail to understand what's going on this connection. Is this a read operation? Is it a write operation? Is it a login attempt? Is that login successful or was it failed? Now let's look at that same transaction through the lens of the leading NDR solution in the space, whose logo may or may not appear on the screen. And here we see that when we have the full richness of packet data available to us, we can see not only did a breach not occur, no customer records were accessed, but we see that this was a failed login attempt. We know this because we see the access denied error code right there in the error response field. So this is something that is probably not even worth alerting on. If this was a privileged user, maybe. Notice we see the username there as well. But by and large, this is an alert that need not send defenders on a wild goose chase. And we know that because we can see it right there in the data. All right, so second example. Let's take a look at some guard duty findings for some SSH brute force attempts. Now, these can be pretty scary. Here we're flagging, guard duty is flagging some attempts to access these AWS EC2 instances over SSH. And we know that guard duty is looking at SSH because it tells us that this is why the finding was generated. But there's this interesting note here that if your SSH services are using other ports, you don't get a finding at all. And this is highly problematic for defenders, right? This is a great example of a visibility gap attributable to some shallow log data. which is what guard duty is applying machine learning to. So no SSH on another port, no finding. Now, again, the leading NDR solution looking at this same bit of communication is able to easily handle SSH running on any port, in this case 2201, because with the full content of that packet at its disposal, we're able to classify the SSH traffic based on its layer 7 attributes, not just its layer 4 connection attributes like port number. So here we can see that this is an SSH open, and that even the version of that the client and server are using to negotiate the session there. So the bottom line is that it's all about the data. If you have shallow data, your detections end up being largely speculative and very noisy. If you have rich data, then you can benefit from high fidelity detections. Now, the machine learning implication for this is the garbage in, garbage out principle. You can actually get better outcomes by applying even mediocre machine learning algorithms to a richer data set than you can by having sort of the best algorithms in the world apply to a paltry data set. So Brian, I want to do a quick time check. How are we doing?
It's actually on time, so actually exactly on time.
Okay.
It's a perfect job. And so we can take one question, I think, before we move to the panel discussion.
Okay.
Yeah.
Yep.
So
a couple more slides, but yeah, that's no problem. I'm happy to take a question if there are any in the chat.
Okay, wonderful. So are you wrapping up, or you still have a couple of slides? Just I want to let you finish.
Well, let me just do 2 slides about
okay, yeah, sure.
our solution, and then we'll wrap it up there.
Yeah. Okay.
Great. So I want to mention that there's really 3. When you think about deploying an NDR solution in the cloud, there's really 3 aspects to it, and all of these aspects can be really automated for us using the cloud's native event-driven automation capabilities. And so the 3 components to consider are packet acquisition, sensor deployment, so the thing that's actually analyzing the packets, and then incident response, whether that incident response be around investigating and triaging some sort of detection, or even automated containment. And so I'll just briefly describe that with clouds, public clouds like Amazon and GCP, we're able to leverage native packet mirroring capabilities, including AWS VPC traffic mirroring, to agentlessly acquire packets from cloud workloads. And we're able to use infrastructure as code solutions like Terraform or CloudFormation or Azure Resource Manager templates to deploy the sensors in situ next to workloads to analyze those packets. And then, of course, from an incident response perspective, we're able to leverage Lambda functions in Amazon or Azure functions, etc., to automatically quarantine offenders that are detected to be attacking our systems, or even compromised workloads within our systems. So I'll leave it there, and I'm happy to look at a question.
All right, excellent. Thank you very much, Jeff. Just one quick question, I think, from people here point out. So sounds like you capture the network traffic, network packet, and you mentioned that the data collection is expensive. Is that like when you collect all those network data, is that also very expensive? And like you need to collect a huge data, right?
Yeah, that's a fantastic question. So the short answer is no. So in the Amazon side and the GCP side, the way that they've implemented their native traffic mirroring capabilities is that you're charged a fixed rate regardless of how much traffic you're actually mirroring. And it comes out to, like, I'll say the list price for Amazon traffic mirroring is around 11 bucks a month, per VM. And so, and again, that's the before customer discounts kick in. So it turns out that not only is the feature inexpensive to use, but it doesn't vary, so you can send a fire hose worth of traffic or a little trickle, and you still have a very predictable, very affordable cost model.